actually what we do. We turn first to our table of contents, and under line 1 of your table of contents, you're going to write understanding real numbers and operations, which is our objective of the day. If you're ever wondering what line we're on, I would always just quietly ask my neighbor in my group, hey, what line are you on? It's much easier than asking me because I teach 5 different classes that I use this notebook in, which means I'm on a different page in each class. If you just ask your neighbor quietly, hey, what number are we on? That way you're on the same line. I also like to write the date so that I know what date it is. After you write both of those in your table of contents, turn to page 1. And in the margin of page 1, rewrite that objective again. That way our pages always match up. If ever you are absent, I will never print the notes for you. These notes are on Edline already for you in PDF form. And you can always go to Computer Lab 326 during homeroom and print these out. It takes you about 2 minutes to log on the computer, get into your Edline account and print that out. Or you have a second option. When you come in, if you're absent, all you do is look at the person beside you or across from you or however and say, hey, did you take notes yesterday? Can I borrow them? That quick, that simple. You can then copy the notes, and I'm fine with you copying notes. Sound good? Okay. So today we're going to start with some vocab. And our first piece of vocab is real numbers. So go ahead and write that down. And can anybody tell me anything that you know about real numbers? Or maybe an example of a real number. Jake. Okay. A whole number is a real number. That is correct. Anybody else? They are decimals. That is also correct. Jake? You go by Jacob or Jake? Okay. That is also correct, Jacob. You look different than your picture on this. Sorry. Sometimes it's hard. When your picture's only this big and it's in black and white, it's kind of hard sometimes. So, all right. Decimals also. Anything else? Okay. So my definition that we're going to be using is any positive or negative whole number. That includes decimals. That includes whole numbers. So it's any positive or negative whole number. There are 2 types of real numbers. And those types are rational and irrational. You just need to write the word rational for now. And notice how I indented it. How many of you have ever done an outline in English or some other class? That's what this is. It's like an outline. Okay? So rational. Anybody want to take a guess what a rational number is? Raise your hand if you want to take a guess or give me an example, whatever. Even number? Okay, they could be even. Just so you know, they could be odd. They could be numbers without decimals, or they could have decimals. I know, it's like 50, isn't it? They could be positive, or they could be negative. Ooh. A rational number is any number that can be written as a fraction. Any number that can be written as a fraction. So 7 is 7 over 1. 1/8 is a fraction. 2.7 technically is a fraction. 2 and 7/10, right? What about 0.5? Would that be rational? What do you guys think? Yeah, 0.5 is 1/2. What about 0.3333333? fractions. We'll talk about those that don't repeat here in a minute, but there are three types of rational numbers I want to discuss in here. Integers, whole numbers, and natural numbers. Integers, whole numbers, and natural numbers. Raise your hand if you can tell me what an integer is. I want to take a guess. I like my guesses. Jacob. Positive and negative whole numbers. Ah. Very good. I actually like the whole numbers the best because they give me a hint. Whole numbers actually give me a hint at what number helps with them. What number do you see in the word whole? You guys see 0? I see a 0. So it starts with 0 and any positive number. So 0, 1, 2, 3, 4, 5 are whole numbers. Is 0 also an integer? What do you say? Yes, that's right, Mackenzie, it is. Is 0 also rational? Yeah. Is 0 also real? Definitely real. I have 0 money on me right now. Definitely a real thing. Natural numbers, on the other hand, are positive whole numbers. So natural numbers start at 0. I'm sorry, they start at 1. I almost gave the wrong answer there. Natural numbers start at 1. 1, 2, 3, 4, 5. So is 0 a natural number? No. No, it is not. Now, if you're thinking, I'll never need this again, it's something we've gone over before, but I'll never need it again. I have a lovely trig student in my study hall first period today. Actually asked me, Lindsay, I know we went over natural numbers, but does that include 0? And I said, no, it does not. He goes, all right, Mr. Ryan needs to know. Because that was what one of his questions on his homework was on. All right, so we talked about those three. Now, if you notice, rational and irrational are together almost. So rational is any number that can be written as a fraction. What do you think irrational is? Numbers that can't be written as a fraction. Also, I like to say a decimal that does not repeat and goes on forever. Why did I look down to see what standard it was? Really? Can anybody give me an example of a decimal that does not repeat but goes on forever? Pi is correct. Josh, that is correct. Pi is a great one. 3.14159, da 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 da. That's all the further I have memorized. So that's all with real numbers. Let's talk a little bit about imaginary. We're going to get really deep into imaginary numbers. At least give you a good enough understanding you can go on and continue doing imaginary numbers next year. But we don't do that till around January or February. An imaginary number is the square root of a negative number. Up till now, your math teachers always told you you can't take the square root of a negative. But now we're going to tell you, yes, you can if you call it imaginary. If you call it imaginary. What letter do you think goes with imaginary? Let's click on something. Let's go with Sydney. Sydney, what letter do you think goes with imaginary? What one letter do you think would fit best with imaginary? I'll give you a hint. It's in the word. Yeah, it's I. Now, we don't use the capital I, though, Sydney. We actually use a lowercase I. There ASON. And that's something we'll discuss really in depth again in January or February, but I just want to let you know, anytime you see the letter I that's lowercase, it means it's an imaginary number. Make sense? There. Alice, come on up. We're just going to wait just a second. I've got a couple people coffee. You're going to help me on my next activity. Hey, don't worry. Lots of people get to come up today, Alex. Yeah. It's not scary, I promise. So, right here, this is called a plethora circle. Guess what? You don't ever have to know the name of it, I promise. All we're doing is I've given you vocab words that we just went over, and I gave you some random numbers. What I'd like you to do, first give me the pen back. Okay, now you can do this. What I'd like you to do is to pull one word in, any word over here, and one number that fits the definition of that word. So you choose whichever one you want. He chose 52 and whole. Do you guys agree? Lovely. Hand that off to somebody. Tanner's like, I got this. Tanner, can you throw in another word that also matches with 52? It is an integer. Knock that off. Jake. Do you like Jake or Jacob better? Okay. J-Dog. Which other word do you want to pull in? I think we can get another one. There's actually three more. I've got three more that could go in. You have 3 out of 5 chance of getting the right one here. Natural does work. Should I just have 2 others here? Rational and? Yeah, good. Turn that off. Now this time you have to pick JR, right? JR, pick something other than 52 to pull in and then a vocab word that fits it. Sorry, if you pick 52, we've already done it. So. 0. I like 0. Pull in as many vocab words as you know. Okay. Good. Okay. Don't be scared. Keep going. One more. Actually, 2 more. I got 2 more. You want some help with master audience, I allow. Integer is correct. One more. Can anybody else help them out? Yep. There you go. Perfect. So it fits 4 different vocab words, right? All right, hand that off. So my turn to square root of 8. Oh. All right. Most people mess this up, which is okay, because we can discuss it. Honestly, when you come up here, if you mess up, that's fine. It just gives us a chance to discuss and make sure we understand. Okay? So which one of those do you think fits? Not an integer. Remember, an integer are positive and negative whole numbers. So -5, -8. Do you know what this square root of 8 is in your head? Does anybody know? Not 4, because 4 times 4 is 16. Anybody? Not 0.8. 0.8 times 0.8 is actually 0.64. Ah, there you go. 2 point something. But we don't know what that something is without grabbing a calculator, do we? I'll be very honest. We all don't know. That includes this one right here. What that is without a calculator. But you all know what the square root of 9 is, right?
Yeah.
3. And 8 slightly below that, so. Anything else you think maybe? You said 2 point something. And I'll tell you this, it's 2 point something, something else, something else, something else. What kind of number is a decimal that repeats or goes on forever but does not repeat? What is that?
Well,
There you go. Irrational. It is irrational. It's also, anybody else want to know what it is? Anybody else know what else it is? It's real. Perfect. John, that was one of the hardest ones.
thanks
Good
for
job.
giving it to me.
You did pretty well. I'm impressed. All right, you can hand me that. Sorry. I'm going to pull this one in. It's our last one we really need to talk about. And which is the one it fits? It only fits imaginary. That's it. Make sense? Okay. I won't try to trick you on a quiz. I won't give you something ugly. If it is imaginary, it will have an I with it. Stands for imaginary. There we go. So now, you don't need to write down the words here. All I need you to do in your notebook is actually write them from lowest to highest, or least to greatest, or smallest to biggest, however you like to say it. Just write those numbers in order. Bless you. Write those numbers in order for us. And then we're randomly going to pick on somebody. Well, it's not really random. Anybody that hasn't talked yet may be talking. I'll have an answer. All right. Dom, pick somebody that hasn't talked yet. No, real name. I'm still working on names. You don't do that. You can stay there, Colin. All I need you to do is read out your answer. I agree. I agree completely. Now, if anybody is willing here, anybody willing to say, oh, I had them backwards? Nobody in this room willing? Okay, that's all right. Or you guys all had it great. We'll say that. In every one of my classes so far today, they've gotten it backwards. I will tell you right now, Colin, you're going to like this. That's an SAT question. In fact, it's one of the easiest ones on there, Dom. Okay? But it gives you some easy points for the SATs to do well. So that's a great way to start. Now, let's give everybody a few minutes to read this. And by a few minutes, I just mean a few seconds, Colin. And then you're going to pick somebody. Don't give any hints away of who you're going to pick yet. Give us the answer there. Try to pick somebody that may not be like a boy. Because I've had like 8 boys come up so far. Try to pick a girl. I would say, real quick, just so you know, guys are definitely outnumbering the girls in this class. I had to look around for a second. No wonder guys were coming up so often. Susie, which number is below negative 60? Negative 40. That's also an SAT question. Okay. Now, will this exact question be on the SATs? No. Where did I find this? On the SAT website. Yeah. I like to throw those in for you also. At this time, take a few minutes, copy down this chart, and then we'll start filling it in. Now we're back. So I asked you guys to discuss in your groups quickly about any of those vocab words, and I heard some things like I never heard of, and that's fine. That's perfectly fine with me. But raise your hand if you can tell me about any of those vocab words. You can choose. Angela, not Mackenzie. Angela. Good. Okay, I agree. can you tell me about the operations in the distributed property? Okay. What operations though do we use? Multiplication's definitely one that we have to have. That's my order of operations. I'm looking for what two operations are in the distributed property. So far we have one. Addition. It could also, just so you know, be subtraction. Okay? So it doesn't matter which one it is, but either addition or subtraction. So you guys came up with a good one. Let me give you my example. There it is. Oh, it's magic, right? I know. I worked on these over the summer. I only got through part of chapter 1, so don't get excited in chapter 2. So I use 3 times 2 plus 7, which is 3 times 2, and 3 times 7. Notice there must be 2 operations. And I forgot to do something. This first column, just so you know, is for my addition property. And the second column is for multiplication, which you'll see here in a second. But that's why the distributive property does not have a line through it. It actually uses both. Okay? Anybody else raise your hand, tell me anything about another property. Jacob. Good. The identity property is something plus 0. For addition, now here's what you need to think of. What number can I add that I get the exact same number back? If I look in a mirror, I always see myself, right? Okay, that's the same thing. This is like your meal. The zero's like your meal. Okay? All right, somebody else give me something about another property. Any other property? Michaela, right? Michaela. Yes. Now I don't actually use the A and B and C, but I will let you know by having that understood already, you will do very well in geometry class. Because that's what he uses. So I will use numbers though. 3 plus 5 is the exact same thing as 5 plus 3. So I like to put words together to help myself before I take your answer then. Commutative reminds me of commuting. You guys heard of the word commuting before? A lot of people commute to work. I commute to work every day. I go from my house to work. And then I go from work to home. Is that distance the exact same? Even though I switch directions? Right. It is the exact same. Even though I switch directions, it's still the exact same number, which is why that works. Josh. Noah. Good. Except I use 7 times 2 and 2 times 7. It really doesn't matter. It's just I had it already typed up, Noah. So that's the only reason I used that. All right. Jake? Yeah, if I multiply by 1, I get that same number back. That's right. Look at us emptying these quick. Okay, anything else? Oh. Wait. You use 2 operations there. You can only use 1. You're on it, though. Good. So I'll use some numbers to help us with the example. Now, once again, notice Jacob used the same operation, where distributive property is using 2 operations. I like to think of this like the friend property. You associate with your friends, right? So, let's say these 2 are my friends. I see Tanner first, so I tell him a story. Then I see then I see Alex, and I tell him the same story. Does it matter that I told Tanner first and then Alex? No, let's say the next day I have another story, so I see Alex first, I tell him the story first, then I tell Tanner. Doesn't matter. They all have the same information, don't they? It's a friend property is what I like to think of it like. So sticking with that exact same way, there's your multiplication. Works the exact same. Once again, notice only one operation. This last property is the one that most people don't actually know. Inverse. Inverse means opposite. You guys are going to talk about inverse quite a bit. In fact, when you solve an equation like x plus 2 equals 5, you use the inverse operation. You subtract 2, right? So inverse of addition is actually going to get us back our identity number. So let's use the number 5. 5 plus what would get me 0? Negative 5. So inverse just means I use the positive and the negative number to get that 0 back. This last one is the tough one. And in fact, it's so tough, I'm willing to give you a piece of candy if you can give me an example for the inverse of multiplication. That means you need to find two numbers. By the way, they can't be 1 and 1. Okay? So two numbers that if I multiply them together, they equal 1. Yep. It's 0.25. Good guess. I like guesses. I told you this is a tough one. If you get it, you do get candy for this one. It doesn't get offered very often. No. 2 times negative 2 is negative 4. You have to be able to multiply them. And I'm looking for once you multiply, they equal 1. Does equal 1, but is not technically inverse. You got my other one that I forgot about. I took out the number 1. I forgot about the negative 1. Equal 4. So in order to do inverse, for multiplication, you actually have to use the reciprocal. You have to use the reciprocal. No, you do not get all these things. You can pick your favorite color. And if you pick red, okay. This is the man that still likes it. Comes in every day to get a red one. Okay. Does that make sense? We've got actually only one page left, which is this one. So I'd like you to, you don't have to write down this lovely stuff up here. You can just write down the problem and write your answer. I do like that you write the problem so that when you're looking back in your notes, you have that. On homework, though, or essential work, you do not have to write the problem down. All good? Angela, who do you want to pick that hasn't talked yet today? Josh, what'd you get? Okay, that's all right. I disagree. Nope. Yes. I am picky, by the way. I am very, very picky. 910 feet. That's the picky part. I don't know if you mean 910 cows that you own. I don't know, it's 910 paper clips. That's how many do you know? problem, please write this entire thing down and then see if you can solve it. It is our last one. If you need to discuss with your group, that's why you have them. Alright. You guys ready? Josh. So here's just something to know about my classroom. I don't like to pick on people, like just randomly, unless I feel like you have enough time to discuss and come up with some sort of answer. So I'd like you to pick somebody that's in this class that hasn't talked yet. Just tell me what the word quotient means. What operation goes with quotient? What operation goes with quotient, Shane? Not multiplication. Division. Quotient means division. That's something you probably need to know. So in this case, my problem would be 3 divided by 1/7. Yes, you need to write that because that's for work. Raise your hand and tell me how to do this stuff. Oh, I haven't heard from you yet. I forgot, I don't know your name. Haley. Good, which is? Perfect. So you multiply by the reciprocal of the second fraction. So she actually used some key vocab words. In case you haven't heard it that way, some of your teachers have said this: keep, change, flip. I like the word reciprocal much better than keep, change, flip, but I'm okay with either, however you remember it. And now we're on to our lovely essential work, which is posted here. We will stop the